Hello, everyone. I'm Tiff Bortwood, the Managing Director of Australian Genomics. Welcome to DNA Dialogue, the webinar series where we share new developments in health genomics and hear from leaders internationally in the field. I would like to begin by acknowledging the traditional custodians of country throughout the lands we're dialing in from today. I'm joining you from the lands of the Wurundjeri Woiwurrung people in Naarm or Melbourne, and I'd like to extend my respects to elders past and present, and also extend that respect to all Aboriginal and Torres Strait Islander people joining us today. We're very excited about today's seminar, and we would like you all to contribute to the conversation by using the Q&A function during the presentation, and I'll do my best to get to as many of your questions as I can in the Q&A time at the end of the presentation. If you're active on social media, please use the hashtag DNA Dialogue and tag @OzGenomics. So our presenter today is Kelly Ormond. Now, Kelly is a genetic counsellor and LC researcher at the Health Ethics and Policy Lab at ETH Zürich. She trained in genetic counselling and clinical medical ethics in the US and joined the Health Ethics and Policy Lab in 2021, though she remains connected to the Department of Genetics at Stanford. Prior to joining ETH, Kelly practiced as a clinical genetic counsellor and program director in the US for more than 25 years. So she really joins us today with a wealth of clinical as well as academic experience. Her bioethics research focuses on the intersection between genetics and ethics, particularly around the translation of new genetic technologies into clinical practice, patient decision-making, consent and the disclosure of genetic test results, personalised medicine, and the interface between genetics and disability. Today, Kelly will be exploring with us the ethical and social issues for somatic prenatal and germline gene editing. Very pertinent discussion as gene editing becomes a reality for rare disease. Kelly, welcome. Thank you so much for joining us.
Well, thank you for having me and for such a nice introduction. It's always a pleasure to speak with my colleagues in Australia and New Zealand, so I really appreciate the invitation.
Oh, thank you. No, we're delighted to have you. Now, I will pass over to you to share your screen and we'll ensure that's all working, and then I will see you again at the Q&A session at the end.
Perfect. Can you see that?
That looks excellent. Take it away.
Okay. Terrific. All right. Well, thanks again for the invitation to speak today on one of my favorite topics and something that I feel like I've really been thinking about and researching for, 7 or 8 years at least now, perhaps a little bit longer. And so what I'm going to try to do is give you an overview of what's going on with gene editing, primarily focusing on the ethical and social implications of this work. And in terms of conflicts of interest, I do want to mention that I am part of an NIH-funded grant that is looking at some of these issues right now, and that I don't have any financial interests in any of the companies that may come up on my slides. So, of course, all of you are going to be well aware of how CRISPR has been developing in the past, decade approximately, and how exciting it was that it was recognized with the Nobel Prize a couple of years ago. And I think that it really speaks to how interesting and attractive this is on a social level, the amount of attention that it's gotten in the press as well. A lot of that press, though, of course, is hype. And so as clinicians, we often are faced by patients who are asking, well, what's real? How often, how quickly is this going to be happening? And part of what I want to start off with is a little bit of that comparison of the hype compared to what we're hoping really does happen. Outside of healthcare, we know that CRISPR and gene editing is going to make a big difference in lots of parts of our world. Certainly, we're seeing agricultural impacts right now. But we're also seeing people who are talking about things that seem a little bit like science fiction here. Certainly recreating extinct animals does seem like science fiction, but you'll see a lot of my clips in a moment that suggest that people are working quite hard at this. But we may also see real public health impacts if we're looking at things like ending malaria through CRISPR-edited mosquitoes. Nonetheless, people like to have headlines like these, and you can see there are lots of different experiences where people are trying to do this de-extinction approach. We also have people in the biohacker world who are talking about doing editing of themselves. And this was one that I took an image of on my phone one morning when I woke up, and this was on my news feed. But this is the stuff that I think probably attracts most of us who work in clinical genetics, this notion that we can treat our patients finally, after many, many years of talking about gene therapy approaches, that we may actually be able to make this difference. And so that's really what I'm going to focus on, primarily somatic. I'll touch on the prenatal aspects a little bit, and then of course we'll talk about germline gene editing as well. And for those of you who are coming from the clinical genetics background, you'll know that I'm also coming from this focus where we're thinking not only about an individual, but also about the impact on their family and how this is going to sort of ripple out into our community and our society. The next thing that I want to mention is that, of course, none of the issues that we're talking about here are completely new to what we're thinking about. And many people will ask, well, what's the difference between gene therapy and gene editing? A lot of the ethical issues are going to be exactly the same. A lot of the way that the public and our individuals and patient families are thinking about this are going to be the same. And so I would refer you back to this very nice article that came out, I think in the New England Journal a couple of years ago, that really talks about historical ethics around gene transfer. And as you can see from this first slide, we've been talking about this for a long time, and people have been doing these experiments for a long time. And I look at this slide and I remember when I was doing my graduate level training in genetics, it was really in the early 90s when we were first hearing about this, and we thought to ourselves, oh, this is going to really change the way that we treat genetic disease very quickly. And fast forward to 30 years later, and now it's finally becoming a reality. So again, there have been many times across these past 30 or so years when people have been moving this technology forward into clinical trials. And when we talk about Jesse Gelsinger, and we will talk about him a little bit more again, that really kind of shut things down for a significant period of time. And we had a lot of stigma that we had to overcome after that. So reality-wise, gene therapies did really move into out of the clinical trial stage and into the clinic about 5 years ago. These are some images that I captured in like late 2017, early 2018, when the FDA initially approved Luxturna for a form of congenital blindness. And that's one of the ones that we've heard about. There are gene therapies have been approved in many countries at this point, and I'll show you a slide in a second. But as far as what's going on in Australia, there were two really nice articles that I found published within the past year or two that outlined all of the approved gene therapies in Australia. And you can see here the range, certainly the spinal muscular atrophy treatments here, the inherited retinal dystrophy, this is the Luxturna I just mentioned, and then cardiovascular disease and some different cancers. This is a similar image from the second paper that I found. And again, you can see that it lays things out in a slightly different way than the image on the last slide, giving you a sense also of how much this is costing, as well as what the eligibility for the different treatments are. So it is happening. We're absolutely seeing both gene therapies and gene editing happening. And you can see here, this was from one of the websites I was looking at that was talking about approvals and updates on what's happening in the trials world, very much going on around the hemoglobinopathies, I would say. But you can also see alpha-1 antitrypsin, and again, more cardiovascular disease. This is one of the most exciting examples that I think we saw. And if any of you tuned in to the Gene Editing Summit that happened in London in March, you would have seen Victoria Gray talking about her experience being one of the first sickle cell patients treated in the United States with CRISPR gene editing. And she's doing terrific. And this study that came out in the New England Journal about 1.5 years ago really showed that after more than 1 year, her gene editing had worked tremendously well, and she really is essentially cured. And I would recommend, if you haven't listened to her talk about her experience, it's really powerful to just hear how much this has changed her life in a positive way. But it's also really powerful to hear. We sometimes imagine this is just a transfusion and we're going to get the gene edited cells into your body and it's all going to be great. And we forget sometimes that, in fact, it's just like going through a bone marrow transplant or a stem cell transplant. You have to go through chemoablation, and that's a quite complicated procedure as well to get to this point. So these therapies are now moving into the clinical stage and starting to really think about the regulatory reviews in different countries. And we're now seeing additional genes being edited in trials. You can see here we've got amyloidosis, the Leber congenital amaurosis, and some beta thalassemias. Some of these trials are working better than others. Beyond this, we're seeing a lot of gene editing going into trials on some of the different cardiovascular genes. So you can see familial hypercholesterolemia, more challenging systemic conditions like Duchenne, some of the additional amyloids, and of course the trial that's happening in New Zealand around the familial hypercholesterolemia, which I'm sure you're all well aware of. We're seeing things that are emerging now around hypertrophic cardiomyopathy. And this was an article that came out about a month ago, and a slide image that Eric Topol posted on his Twitter post, thinking about whether or not we would be able to move beyond some of these Mendelian conditions to even repairing damaged hearts after a heart attack. And then this is a really exciting notion to think about, the idea of doing epigenomic genome editing. And this was a news article that came out just last week, where they're using epigenome editing to cut cholesterol levels in monkeys, showing that this would be a realistic possibility. And the thing that's exciting about epigenome editing is that we could up or down regulate genes in different ways, and also ways where it might potentially be reversible. So if you think 5 to 10 years down the line, this could be a really interesting and exciting way that gene editing may go. I didn't make a slide for it, but we are also beginning to see, at least in the United States, at UCSF and a couple of other places, people who are trying to deliver gene editing prenatally, which is kind of this interesting in between of somatic and the earlier editing notions, and that could have really interesting potential for conditions where early treatment is especially important. So you might imagine something like PKU, where the sooner you can intervene, the better the outcomes are going to be. You may want to have a prenatal delivery process there. That's going to raise different issues from somatic gene editing, in that we're also involving the mother in the treatment, and we would need to think about risks to her as well. So what I want to do now is just do a quick flashback to April 2015, when we began to think about the notion that genome editing could be done in human embryos. And these were the first two papers that came. This was the first paper that came out of China, showing that in tripronuclear zygotes, they could do gene editing, and the accompanying editorial. And this immediately led to some strong statements by a number of individuals, including David Baltimore, who was part of the original group in the 70s who talked about genome modification, and they were seeking a moratorium. And this was when I was, at the time, the chair of the Social Issues Committee for the American Society of Human Genetics. And we began to think, all right, we really need to be thinking about how we're going to regulate this and what position statements we may want to have. It really picked up as we began to see statements from the UK, where they were looking for licenses to do some basic science research on germline gene editing in embryos. And then we saw several more papers demonstrating that, in fact, this could be done on different types of embryos. And then this was a paper that came out in 2017 out of the US and a group in Oregon. So at that point in 2015, the National Academy of Science and Medicine in the US, along with the groups from the UK and the Chinese Medical Society, held a large summit in Washington, DC. And this is a screenshot of the statement that came out in February of 2017, thinking about where they were at that point in time in terms of recommendations. And you can see here that all of the groups at that time were supporting basic science research, primarily to see how this was working. They were generally supportive of things that might move somatic gene editing forward, emphasizing that they needed some more broad public input, and I'll talk about that quite a lot during this talk. They were not particularly supportive of the germline gene editing and really wanted to limit that sort of clinical research. And for enhancement, they had a strong statement to not proceed with research in this area. And so things moved on, and on the eve of the second summit that they were going to host in Hong Kong, this is a screenshot of something that came up on my news feed that evening, and they broke the news that a Chinese scientist had reported the birth of 2 babies that had been gene edited. And this was really shocking to everyone at the summit. I think it really turned that summit upside down. And there was a lot of news after that about how this had happened and the scientific misconduct that had happened here. Ultimately, this researcher was put into jail. He's been recently released from prison about a year ago and has resurfaced trying to propose additional research in this area. And there was a lot of news about who knew and at what point they knew and how this could have been better regulated. And I think, of course, it raises the question, when we're doing new research like this, at what point do we start to think about the ethics? And how do we begin to say, we shouldn't even try to do this, we shouldn't move forward at this stage, and who regulates that? So these are important questions. Many professional societies have released statements, and at that time, really starting in about 2015, I was involved in helping to write the ASHG position statement, which was sort of seconded by many associations around the world. Since then, other societies have written their own statements, and I have the ESHG statement here as just one example. Many of these statements, and this was a table from our original ASHG position statement, many of these statements were consistent on a number of different levels, and you can see we tried to look at what people were commenting on. Most societies and position statements were supporting basic research, but felt at that time that germline gene editing was not ready to proceed in any clinical research standpoint. And there were statements that were thinking primarily about safety and efficacy at that point, but sort of vaguely raising issues around oversight and around justice and equity and transparency. We've seen since then lots and lots of organizations make statements. So this is a picture of the 2017 National Academy statement that came out of the US and the Nuffield statement that came out of the UK in 2018. And then in 2020, we had a second study report from the National Academies and the Royal Society. That came out after the second summit that happened. An update on the Nuffield Council statement, and then the EU has recently released a statement on the ethics of genome editing. The WHO has recently released a statement. And this raises the question, when we have a lot of variation in how regulation is happening, how do we think about global or humankind regulation of what's happening? And the picture on your left right now is an image from a paper that my colleague Rosie Azizi published probably more than 5 years ago. And you can see it looks at lots of different sorts of embryo research and clinical relationships to things. And even if you don't pay attention to what the colors mean, the take-home point here is that there's a lot of variation around the world in terms of what's considered acceptable and what's considered restricted. So when you have individual countries that all have their own governance, there's not one individual thing within our whole globe that regulates things in a way that actually has repercussions. And that's a real serious issue. And you can see here again, I have an image on the right. Embryo research is a real serious concern as far as how policymakers are thinking about regulation. And as we do more embryo research, not just gene editing related research, but any kind of embryo research, it's hard to think about how we're going to regulate that properly. This is a slide from a very recent publication by Francois Baylis, where they actually looked at what are the policies on human germline gene editing across the globe. There are some countries where they didn't find relevant information, and you'll notice that Australia and New Zealand are sort of grayed out without information in that particular study. But you can see, again, lots of variation across the world. And the WHO has put together this international work group and released their guidances as well. But as you can see in the quote here, the WHO is recommending against using heritable human genome editing, but they have no powers of enforcement. And this continues to be a challenge. So it is still in a lot of ways based on guidelines of these international professional bodies and about the countries choosing to go along with these recommendations. So I want to switch gears a little bit here. As scientists and as bioethicists and as clinicians, we often make a very big difference between somatic gene editing and germline gene editing. But an interesting question is, what does the rest of the public think about this? Do they see them as so different? And this is a paper that came out, I think in Science, maybe about 4 or 5 years ago. It was based on a US public study that looked at a few thousand individuals. And what they found, if you look at this slide, is that in terms of agreement with somatic therapy and germline gene therapy, you can see those numbers are almost the same in terms of those who agree or are neutral on it. And similarly, with enhancement, you can see there's a little bit more approval for something that would be somatic than germline, but it's not like that breakdown that you often see when you talk to scientists, where they might say something like, well, somatic gene editing, that's really the same as any other treatment. It's the same as gene therapy. Of course, we might support that. And germline, oh, no, we can't do that. So we're not seeing the same sort of difference in public trials. And that rings true with some of the studies that we've conducted as well. And I'll give you some further examples. So what I want to do now in the remainder of my time, which is probably about 20, 25 more minutes, is to dig in to some of the ethical issues a bit more deeply. And if we go back to this original slide from 2017's position statement out of the National Academies, you can see that within the somatic genome editing realm, right, we're dealing with this now. We've got active clinical trials going on. 2 of the points that they made were about existing regulation and safety and efficacy. And of course, when we think about bioethics, we don't want to move into research or clinical experiences if we don't have clear information about safety and efficacy. So that is always going to be critical at the beginning. And then I think we need to trust that within any country, we have appropriate regulatory processes that are going to oversee when we can move into offering these procedures. But unfortunately, I think that the focus has been very much on these 2 things and less so on the other points. And I really do want to move into thinking about how patients and families now are thinking about gene editing treatments. And it's really this. They're hoping that this is the cure or the treatment for their condition in a lot of cases. And they're hoping that it's going to make their lives better. It's going to improve their quality of lives. And again, you can see that from these 3 screenshots that I showed you earlier on. We're focused on this. Does it work? Are we going to have off-target mutations? How many? What's the impact? How can we assess those? We're focused on this part. Patients and families are absolutely also focused on this question of, is it safe? And this goes back again to Jesse Gelsinger's death in 1999. And I'm guessing that most of you know this story, but he was a teenager, basically, and he was part of an OTC gene therapy trial, and he passed away very tragically. And there were a lot of questions about the manner in which he was recruited into the trial and whether or not he even should have been, and whether or not he should have been treated with the particular gene therapy that he received in the way that it happened. But his is not an isolated event. And this is Terry Horgan, who had Duchenne muscular dystrophy and died in October 2022. So these are some very recent headlines where we're again seeing people are really worried that when we talk about safety, there is an actual death risk from these kinds of treatments. And the most recent headlines from about a month ago suggest that Terry's death was not due to the gene editing and there was another cause for it. But people do get quite worried, especially when we're talking about the first person to actually be trying these treatments, that this could be the outcome. The challenge, of course, is weighing things, right? we're worried about the safety, we're worried about what might happen, but at the same time, we also know from working with these families that there's quite a lot of anxiety to find these treatments. We're talking about, in many cases, very significant conditions that may, in fact, lead to early death. And certainly significant impacts and impairments for some of these conditions. And so we have families begging for these treatments and begging for the approvals to happen more quickly and not be quite as rigorously regulated. So this is a real challenge that I think is going to go on as we see these come to fruition. Here again is that balancing. We have editorials that say things like, we can cure disease by editing a person's DNA. Why aren't we? And then we have other individuals saying, I think there's a lot of pressure pushing these technologies forward, and there's reluctance to regulate, and this is putting people at risk. So again, I think finding that middle ground and moving through that is going to be one of our bigger challenges from a translational standpoint. So now I want to move on and talk a little bit about this second point here, this notion about how we think about disease and disability and how that is going to play out into the translation of these technologies, as well as how the public is thinking about some of these issues. So I'm going to tell you a few stories from research that I've worked on using that as examples, as well as some of my colleagues. And the first is a study by Alyssa Armsby, who was one of my graduate students in genetic counseling at Stanford a few years ago. And she did this study, I think we collected data in 2017. So keep in mind that this data was collected before the babies were born in China who had had germline gene editing. What we did in this study was we sent out a survey to individuals who were registered as members of genetic societies across the globe. So we collected global data. We had about 500 respondents, and we gave them a number of different scenarios and asked them what they were supportive of versus not. And you can see here that in all of our examples, we had higher levels of support for somatic gene editing than germline. So this isn't a super big surprise, but we noticed that people had quite nuanced views about what they were supporting it for. So you can see differences when we look at everything other than prevalence, essentially, in this list. So things like penetrance, if it was highly penetrant, we were seeing more support than if it had low penetrance. If it was earlier onset as compared to later in life, if it was fatal in childhood as compared to not shortening lifespan, and then in terms of the degree of disability and impairment that came along with it, if it was more severe versus mild, we were seeing differences. So again, this is folks who were clinical geneticists, genetic counselors, laboratory genetics people. We also saw a lot of nuance when we gave them examples of things that would be considered treatments versus enhancement. So this first slide is specifically about somatic gene editing. And just to orient you, this color right here, the kind of the peachy pink color, and then the purple are people who are supportive, strongly or generally supportive of it. And you can see these first two things are treatment for something that would cause physical disability and impairment or intellectual. Those are very strongly supported by most individuals. And then enhancement for things like appearance, physical abilities, or cognitive abilities, that support is down here, right? Usually less than 10 to 15%. Now, if we look at what the levels of support were for germline, all of those decrease. So you can see again here, we have treatment for the physical or intellectual conditions. This one is correction of a carrier, so not as much support here, and then enhancement. So I'll flip back just so again, you can remember the difference. This is germline, this one is somatic. So it goes down for all of these. This was really mirrored in a more recent study by some colleagues out of UNC who asked individuals in the US who were clinicians and researchers how much they supported this. So again, I think we're seeing similar sorts of things, strong support for basic science research, support for clinical trials moving into the somatic gene editing, but much less for anything around germline gene editing. And then they gave them some different vignettes giving very specific conditions as compared to the questions that we asked. But it really brings us back to how do patients and families think about their own experience? How do they think about quality of life? How do they relate their identity to the condition that they have? And there's some really nice papers. I love the work that Felicity Boardman has been doing in this area. She's done a number of empiric research studies beyond this editorial that she wrote a couple of years ago. And then I listed an example of an early study that our group at Stanford had done looking at Spinraza, which is nusinersen, and spinal muscular atrophy treatments. So I've been involved with a number of different studies that have been trying to think about germline, or not germline gene editing, gene editing just in general, and different conditions where we thought that we were going to see treatments come out sometime soon, or we had a particular thing that we wanted to look at. And you can see a range of the studies that we've published, as well as some of my colleagues have published in this area. So I'll talk through a couple of those just briefly. The first one here that I want to talk about was spearheaded by another Stanford graduate student at the time, Lily Hoffman Andrews. And we did this study actually thinking about Luxturna, even though it hadn't been released yet, and it was approved in the middle of our study. So that was a really interesting thing to sort of think about how that might have impacted it. But in this study, we interviewed individuals, some of whom had congenital blindness due to Leber's congenital amaurosis, which of course is the target of Luxturna, and some of them had adult onset retinitis pigmentosa. So what we wanted to think about was how their different experiences with blindness impacted their attitudes towards gene editing. And what we did see was that people in general who had congenital blindness felt that their blindness was more a sense of their identity, and they were either neutral or opposed to gene editing. And so here's an example. One of our quotes, even though it comes from an individual with RP, this was what we also were hearing from individuals who had congenital amaurosis. There's this argument of, if you could get your vision back, would you? And a lot of people will say they wouldn't. I think those are for people who are born blind. And if you're born blind, you kind of didn't lose anything. As compared to if you lost your vision in adulthood, we were hearing things like this. I think a lot of people who have RP, and their symptoms start later than mine did, they might be people that would really benefit or be interested in gene editing because they have a harder time adjusting or adapting to their vision loss. And it really does reflect this idea that they've had a loss and they would like to regain their vision in this sense. And then we would hear this as well. That would be a factor. I think if it's a few $1,000s, I would be much more inclined to seriously consider it than if it were a six-figure cost. And if we're talking about only a marginal increase in my vision, then I might be much less inclined than if we're talking about a large enough increase. It would have to have a meaningful impact on the functional utility of the vision I have. So there's a lot of nuance to this. And I think that's really important to remember when we're talking about treating conditions with gene editing or gene therapies, is not everyone who has the same condition is going to think the same, and they are going to really weigh these risks and benefits, both financial risks as well as other risks. Now, we did a series of other studies. We were interested in thinking about how families dealing with cognitive impairments might think about this. And so the studies I'm going to talk about now, which were spearheaded by Erica Snur and then Kate Elliott, while I was at Stanford, drew upon some of the work that Megan Elise and Marcia Michie and Kirsten Reagan had done with families who had children with Down syndrome. And of course, chromosomal aneuploidies are going to be much harder to treat through gene editing. So we were very clear that this was not something that was likely to happen anytime soon, but we wanted to get a sense of how families dealing with the cognitive impairments thought about gene editing or gene therapy type treatments. And so we structured a study where we did interviews with families who had kids with trisomy 21, as well as trisomy 13 and 18, because we wanted to get a sense of this severity spectrum again. And what we saw was that there were a lot of societal implications that people were talking about. So if you glance at this slide here, people were worried that gene editing would create a society that was less tolerant of diversity, less tolerant of disability, and a lot of pressure for the perfect child. And of course, those of you who work in prenatal testing, this really resonates with what we've heard around prenatal diagnosis and what sort of escalated as NIPT has become a real worldwide offering. People were worried that these kinds of treatments would eradicate people who had these trisomies, And they were worried that it wouldn't be a real choice, that if we eliminated some of these conditions, then if you chose not to do the treatment, you would have stigma, you would have judgment, you would be looked upon poorly, and that would be a real challenge. They were also worried about equal access to this technology, and that people who couldn't pay for it or people who didn't have it accessible would have different challenges as well. But we also saw that there was a lot of internal conflict. People could voice that there were parts of the condition that they would really like to be treated. So we heard a lot of things, for example, from families with Down syndrome, where they would say, my child has problems with communicating, and if there were a way that you could do gene editing and it would really fix that, that would make a big difference to our lives. But I struggle with whether or not I would want to do something that might change my child's personality or identity. So there was this real conflict that people could vocalize to us. And we saw this more, I think, with families who had a child with trisomy 21 than families who had a child with trisomy 13 or 18. But they also were many families who had kids with any of these conditions who said, this doesn't really need to be cured. And I sort of resent the notion that we should offer gene editing because that's what it implies. They did, on the other hand, suggest that even if they didn't want to personally use this, they were okay with gene editing being available on a societal level and for other conditions. Finally, we saw that it depended a lot on how people thought about their own perception of their child's identity. So was the trisomy that their child had a series of medical features, or was it their fundamental identity? And you can see these quotes illustrate that a little bit. And then they also reflected on their own identity as a parent. So did parenting a child with a trisomy turn them into a better person in some way or influence their life positively, or did it pose barriers and challenges that they struggled with more? We had a quadrant in our paper that tried to think a little bit about how these things were related, and this notion of perception of the child's identity and perception of their parental identity. And you can see here that it did seem to influence, and again, this is a qualitative study, so we're not supposed to generalize, but we were starting to see some trends that could be further explored in the future about how families might differ in their views towards somatic gene editing and germline. Now, as we get close to wrapping up here, I want to talk a little bit about how we decide what conditions are appropriate for gene editing and who decides this. Now, of course, a lot of this is going to come down to delivery, right? People right now are thinking to themselves, okay, we figured out how to deliver gene editing into the liver, for example. So what are the conditions where we're going to focus on the liver and we can make a big difference easily? So some of this is going to be technological, of course. But a lot of research is driven by other things as well. And you can see here many headlines that are thinking about editing for deafness. And this is something that those of us who work in clinical genetics probably all have a little bit of a shiver about. And many families who are dealing with deafness, I think, also share this. And there's a lot of work I know coming out of Australia around thinking about this in terms of carrier screening and reproductive screening. Many other places talking about it as well. So we need to continue to have these dialogues and really think a lot about who decides what conditions we're offering this for and how that process works, and making sure that we are involving the people who have the lived experiences. Here's another example here, thinking about autism and the Autistic Self-Advocacy Network making a very strong statement. And you can see here that they are saying that they want to make sure that their communities are involved in these conversations. And I think that's especially important. We're also starting to see many global citizens assemblies, and your groups in Australia have really done a great job getting this off the ground and done some great work in this area. The UK Citizens Jury happened, I feel like last fall maybe, and recently published their findings. Their group was a little bit different in the sense that they were trying to get at people who had the lived experience as well. Many countries around the world are doing this. Here in Switzerland, we have been working with colleagues to try to mirror some of these processes, and we're in the stage of writing up the expert interviews that we did last summer, and we're about to release a national public survey to try to address how people feel about somatic and germline gene editing, with the hopes of doing a deliberative democracy event in 2024. So I think it's really important that we're engaging the public on this in different ways. The Netherlands has a couple of really interesting papers that are out, and some grants that are run by a number of different individuals you can see here, really trying to educate the public about gene editing, mostly focused in their case on germline gene editing. So justice and access. I think we've been talking about this on a number of different levels. The thing that you hear the most about is the cost, right? The images on the left really focus on how expensive these therapies are, and there have been a number of articles that talk about that gene therapies and cellular-based treatments like this are the most expensive treatments that are on the market right now. So that is a huge issue, certainly for anyone who lives in a country where government-sponsored healthcare is part of the process. It's going to impact what gets approved and how it gets approved. And we're going to need to really think about how that plays out on a global level. But the other access issue that I want to talk about is this notion that many of the treatments that are being developed right now are quite mutation specific. And so this is an image from the New York Times thinking about cystic fibrosis and individuals where, depending on what mutation you have, you can or cannot get into clinical trials. We're definitely seeing that with Duchenne muscular dystrophy as well. But I think this will be something that we'll need to keep an eye on. Going back to the experience of the babies born in China after the germline gene editing, we also need to think about how we're going to support ethical behavior in our colleagues. And having been at Stanford at the time that this happened, and knowing individuals like the Chinese researcher was in a Stanford lab as a postdoc for a while, there were people who at Stanford potentially knew that this was happening and were my colleagues. And so that was a big question about what people knew, how we might report things. And as a result, the WHO did open a registry where individuals are required to enter any international clinical trials. So hopefully that will help. But again, I think we need to just remind ourselves that we are the stewards of our science. And if we do learn of things that are happening that are unethical, we need to find ways to reach out and make sure that we're supporting the most ethical behavior. It's a real challenge, I think, and I just really want to emphasize that. And so with that, I think we have about 15 minutes for questions and comments, and hopefully we'll get a good dialogue going to think a little bit more about how this will play out for us in a translational manner. So thanks for your attention and for choosing to spend your afternoon, and happy to take questions at this point.
Kelly, thank you so much. What a fascinating exploration and journey. It does certainly feel like a brave new frontier, but also, you know, the cautions that you explored are just fascinating. We have got good questions already on the chat. I might start with one. So there's a comment, so just more around the paradox of the risk of harm from treatments and uncertainty of the outcomes, but from those with lived experience, the urgency of access. So not a question, but a comment from Shani. As someone who cares for a person with serious life-limiting rare genetic disease, I have much greater concern about the cost of these treatments and access to treatment than any other factor. For precision medicine therapies that already have regulatory approval, currently the vast majority of patients are unable to access these amazing treatments due to the prohibitive cost. It's particularly mentally challenging knowing that there are effective treatments out there and no possibility of ever getting them. Thank you, Shani.
Yeah, I mean, Shani, I think the answer to this is absolutely, that is the hugest problem that we're facing right now. And the bulk of the discussions at the Gene Editing Summit in London were about access. And I really think that this is such a key issue that we need to address globally. They gave some examples there. I mean, of course, around sickle cell, which is one of the areas where these treatments have moved the quickest. And we're talking about individuals who, the bulk of the individuals in the globe who have sickle cell and thalassemia are in Africa and India. And these are the places, the gentleman from the thalassemia group in India said, we don't even have hydroxyurea, and that's been available for 40 years. Like, how on earth are we going to make this happen? And I think it's really going to require turning the pharmaceutical world and the way that we think about drug costs upside down in order to be able to make this accessible to people in a just way across the world. I do not have an answer, obviously, because this is a super complex problem, but I think it's a tremendous problem.
Mm. Mm. So we have a question, a bit of a curly one from Bob Phelps for you. How do we guard against the re-emergence of eugenics? Some leading proponents of heritable human genome editing argue that rather than being merely morally permissible, many instances of genome editing will be moral imperatives and will be morally required in some instances. He goes on to speak to human augmentation and sort of the gaming that might happen between nations associated with that. But would you like to comment to his original sort of thrust about the re-emergence of eugenics?
Yeah, I mean, again, I think you guys are giving me all the great relevant questions, and that's one of the biggest worries, is that this is going to move in that direction. And I think that it is unfortunately realistic that we're going to be able to do things that fit into enhancement, and it's going to be distributed differentially across the globe, and we're going to need to really wrestle with those questions. And I think that as human geneticists, we've often tried to put our head in the sand a bit about eugenics and say, oh, no, we're not doing it. And I think we as professionals need to have a real reckoning about what that plays out as and how it may come across and how we feel about it within our own societies as well as with the public, because otherwise it's going to take off and we're not going to have a lot of control over it. So I do worry that things will happen and then emerge quickly with less regulation and restriction there. I struggle a bit with the beginning part around our obligations. That is not my own personal ethical view, although I know that there are many very prominent philosophers who feel strongly that that could be the case, that it could be morally required if it becomes available. That is not my personal view, but I think we have to have those conversations as well. And I think we need to really think about what it means deeply to be human and how we think about this notion of enhancement. You know, we have things that we do already that fit into categories of enhancement that society feels comfortable with. I think we feel less comfortable with things like this that would be considered an enhancement, but we don't really have rigorous societal dialogues about that. It's kind of the yuck factor response stops the conversations in a lot of cases. So I don't know that I have an answer per se, but I think we need to be having those dialogues.
And it's interesting too, I mean, your response harkens to the data you presented on cognitive impairments and how people in, you know, genetic professionals were more comfortable with, you know, noting the relevance to severity, but, you know, the use of gene therapies for the purposes of intellectual disability management, but then cognitive enhancement was definitely a no-no in there, you know, according to the data.
Yeah, absolutely. And I think too, I mean, we have to remember that as medical professionals, we are still trained in this medical model of disability, this notion that there's a pathology and we're supposed to find a way to fix it. Many of us, I think, given our experiences working with patients and families, have moved towards a more social model of impairment and disability and thinking about how individuals who have these lived experiences really regularly rate their quality of life better than what perhaps a medical professional would imagine it to be, right? And I think we have to begin to merge that a bit better.
Fascinating. Oh, I could talk all day. So we've got a great question from Diane Nickel. Di, welcome. Great talk, Kelly. I'm interested in differences in public attitudes globally and the extent to which these differences might align with current regulation. For example, in Australia, our research tends to suggest that a significant number of people do draw a clear distinction between somatic and germline and have unease about embryo research, though others don't share these concerns. Germline gene editing is clearly prohibited in Australia, despite the grade shading in the Bayliss paper. And it would be really interesting, I think, to compare the attitudes of people in countries with permissive regulation with those with more prohibitive legislation. Are there different regulatory approaches? Are these different regulatory approaches aligned with different community attitudes?
Yeah, I think that's a perfect question, Diane, and I really appreciate it. And I think that's part of why many countries are trying to do research using similar tools, such as the one that your group developed, so that we can make those comparisons. Being in Switzerland, they're also very conservative about embryo research. It is illegal in Switzerland, but we do still have some individuals, who feel more comfortable with it. So I think we need to collect that data. And I think one of the challenges will be that the places that are more permissive, it may be harder to do the comparative research. So for example, there are a lot of questions about what people in China really think about this.
Mm-hmm.
I think there's also some sense of distrust in some of the research that's coming out of those places. So I'm not sure how we're going to parse that in terms of having trustworthy research that we really can compare in those ways, and feeling like it's not sort of government propaganda in one direction or another.
Mm. Yeah, Danya also touches on that point and sort of expands upon it, just wondering about the role of patient and public views could play in developing policy around these areas. So
yeah, Danya, the ultimate policy question, right? I think we need to take it into account, but I also don't feel like just because the public says, yes, we're fine with it, we say, yes, okay, it's all fine. We do know that as technologies come out, historically, there's usually less trust in them, less support on a general public basis. And, you think about IVF or PGD or things like that. 30, 40 years ago, when these were starting, people did feel much more uncomfortable. And now there's a little bit less of that discomfort. It's more of a kind of normal thing these days for many people, obviously not all. But yeah, I think we need to at least hear the voices so that that's taken into account when the policies are developed.
Mm. Well, speaking specifically to the voices of those who work in the area, we've got Chris Elvidge from the Childhood Dementia Initiative asking if anyone's researching gene editing in the brain. I think childhood onset fatal neurodegenerative conditions such as the childhood dementia disorders would be less controversial. And that does reflect in the data you presented around severity, onset, and implications for the experience of the child and the family.
Yeah. Chris, I haven't heard of anybody doing that specific research, and I'm guessing it's because of the delivery challenges. But I do know, for example, that conditions like PKU are being researched in terms of their implications, because that's an easier target in the liver. So, but I think you're raising a really good point.
Gabrielle raises an interesting parallel through IVF and PGT. She works in that area of genetic counselling, and she says she's constantly challenged by what people are wanting to select embryos against. Again, the concept of just because we can, does it mean we should? And hearken to the Jeff Goldblum meme. Thank you for chucking that in. Everyone loves Jeff. It seems regulation is becoming more blurry. Perhaps more of a comment than a question. There's likely to be lessons already learnt.
Yeah, absolutely. I think, we can take a lot of lessons from prenatal diagnosis, from the PGT, from reproductive carrier screening, all of these things. And, again, I trained and practiced in the US, where so much of this was commercially driven, and it was all about more gives you more autonomy, more gives you more options. I don't personally believe that more is always better. And I really think that we have to think together to make good decisions about what is offered, because my own anecdotal experience is that patients often feel that if something is offered, it's because a medical provider thinks there's value in it. I think that, you know, it really does imply if I'm offering it to you, there's some reason.
Yes, and I mean, that comes back to many of the sort of genomic and advanced technologies and interventions.
Yeah.
So we have a question from Peter. What reproductive planning options are being offered to patients receiving somatic therapies? If you rule out off-target consequences, surely pre-implantation genetic selection is producing similar ethical considerations as germline gene therapy, just one step removed.
Yeah, and I think that's part of the argument against germline gene therapy is this idea that if you want to avoid having a child with this condition, you could do PGD and you're done. And of course, for most couples, that is something that would be conceptually possible, even if it's challenging based on the number of embryos and things like that. There will be some where it wouldn't be, and there would be some where it's maybe not going to be the preference in terms of discarding embryos, for example. But I think you've raised an interesting question around the individuals who might have somatic gene editing and then want to go on to have children. Now, something I hadn't thought of before the gene editing summit was when they're doing the preparation to deliver the gene editing, they're doing chemoablation. So they have to essentially, for example, store your gametes. So because you're going to be infertile after this treatment. So that's another issue. It may be that they could consider doing the gene editing on the eggs or sperm in those cases. But again, I was on a call the other day with people who were talking about what might this look like in 5 years, 10 years, 25 years. And one gentleman made the argument, I think we're all going to be having germline gene editing and it won't be a big issue because then you don't have to think about it in the future generations and you don't have to go on after the somatic editing to have it done to have offspring. And I said, well, I don't know, maybe somatic gene editing will be easy, I'll put that in quotes, more widely recommended, and we won't have to think about germline gene editing because it will just be a treatment you do afterwards if you want it. So I think we don't know.
But the field is moving very quickly, though.
It is. It really is. And I think that in 5 years, we're going to look back at this and say, oh, gosh, did we really think that? In a lot of ways.
Look, Kelly, it's in the interest of time. I'm sorry to those who have asked questions and we haven't got to them, but it's been just a fantastic conversation. Thank you so much for joining us today. It's been just terrific.
It's been my pleasure. And thanks for all the great conversations and questions. I really enjoyed it.
Thank you.
All right.
And thank you all for joining us this afternoon. Our next DNA Dialogue seminar will be held on the 29th of June and will feature Professor Olaf Reis delivering a presentation about diagnostics of rare diseases beyond the exome. I hope you can all join us then. Thank you very much.